Application Specialist here at CS Automation.
I'm Dave Betts from SMC Corporation, and today we're going to go over our vacuum test panel. Our customer came to us with 3 problem statements. Number 1 was, what are the best methods for verifying the venturi and vacuum cup for an application? The second was, how do you identify leakage if you have a porous workpiece? And the third problem statement was, what are the best practices for verifying that you have a part before you pick it and place it?
The common method for generating point of use vacuum is to use vacuum injectors. In our enclosure, we have 3: a low flow, mid flow, and high flow ejector. Understanding their construction and how leakage affects their functionality is critical to your system design. In addition to the ejectors, our system has 3 sensors: a positive pressure flow sensor, a vacuum flow sensor, and a vacuum pressure switch. Using these 3 components, you can gather critical system information.
With an injector, the vacuum pressure and flow are determined by the supplied compressed air pressure along with the flow of the compressed air. Here we can record the amount of flow required for the low, mid, and high ejectors with an incoming supply of 0.3 MPa.
First demonstration is, how do you select a vacuum cup with a low vacuum flow venturi? I'm going to turn the vacuum flow on. Whoop. Just barely pick up the part. Much better.
Cup size. Let's learn a little bit how it's actually working. So again, I'm going to turn on our low flow. I'm going to pick up our product. As you see, when the cup is not connected, I'm at about minus 4.4 kPa of vacuum pressure. Connecting the cup to the product, I've now jumped all the way up to 46.3. What that's going to tell me is now I can have an output come on to tell me that I picked up my product, and also would tell how much force I'm generating on my product if it's sensitive to that. At this point, I'm going to take a look at it to see how well am I sealed to my product. In this case, a 3 value would be a perfect seal, no flow in the system. Here you're seeing I'm fluctuating very close to that number, and I have very minimal leakage between my cup and my product.
The problem statement that we want to solve is, how do you determine the actual leakage if you know your workpiece is porous? So we're going to look at a cardboard box. So cardboard is porous. Painted or unpainted, there are different levels of porosity. So what we're going to look at here is, by using our vacuum flow sensor, we can actually quantify what the actual leakage flow is. So the number, when it went below 3, is actually in the vacuum flow range. Documentation for our units is included with this vacuum test panel, but it basically identified somewhere around 1.3 liters a minute of leakage between your vacuum cup and the cardboard work surface.
Partnership with SMC, we're able to take that problem statement and come up with a solution and a tool to meet those needs.
Feel free to direct message Kevin or myself, and we can come on site with components, vacuum cups, and we can actually test them.